Hey Dart developers, today we are delving into the fascinating world of data structures and algorithms, but with a twist. We'll be exploring them through the lens of Dart. Whether you are a seasoned Dart developer or just getting started with the language, this video will equip you with the knowledge and the skill to tackle complex problems with confidence. Let's get started. First thing to do is click on the link in the description, which will take you to this GitHub repo. Clone it to follow along with me. The entire Dart TSA challenges spread across multiple folders. In this video, let's take up the first one. Basic challenge 1 contains 10 problems. As you can see, each problem contains 4 files. One is the solution already written by me. The second one is the test cases to validate the solved problem. Third one is to check the output of a problem in the terminal. The last one is for you to solve. After the problem statement, pause the video and try it yourself. Run the test cases. If all the test cases are passed, congrats, you successfully solved the problem. Compare your solution with mine. If the test cases are failed, see the solution and try again. The first problem statement is to write a function called hello world that returns a string hello world. Now we can move to the solution. This dot code defines a function named hello world which returns a string hello world. Let's break down the code. The first line defines a function named hello world which takes no parameters and returns a value type string. The second line specifies that when the hello world function is called, it should return a string hello world. This string consists of the words hello and the world separated by space and with an exclamation mark at the end. Overall, when you call the function hello world, it simply returns a string hello world, which is common phrase used as a simple greeting or an introductory example in programming tutorials. The problem statement getSum is to write a function called getSum that takes in two numbers and return a sum of those two numbers. Now we can move to the solution. This line defines a function named getSum that takes two parameters num1 and num2, both of type num. The num type is a Dart's generic numeric type which can represent both integers and floating point numbers. This line returns the sum of two input parameters num1 and num2. The plus operator is used to perform addition and the result is returned as the output of the function. Overall, when you call the getSum function with two numeric values as arguments, it will return the sum of those two values. This function is straightforward and demonstrates a basic arithmetic operation in Dart. The third one, calculator problem, is to write a function called calculator that takes in two numbers and an operator and returns the result of that calculation. Now we can move to the solution. This line defines an enumeration named operation with four possible values: addition, subtraction, multiplication and division. Each value corresponds to different arithmetic operations. I just extracted it out to keep the code clean. Now we can move to calculator solution. This line defines a function named calculator that takes three parameters: num1, num2 and operator. Num1 and num2 are the two numbers of which arithmetic operation will be performed, and operator is an instance of operation enumeration indicating which arithmetic operation to perform. This line starts with a switch statement based on the value of the operator parameter. This line defines a case for addition operation. If the operator is operation.addition, the code inside this block will execute. If the operator is addition, this line returns the sum of num1 and num2. Similarly, there are cases defined for subtraction, multiplication and division, each returning the result of corresponding arithmetic operation. This line defines the default case of the switch statement, which means if the operation does not match any of the defined cases, which should not happen in this code, an exception will be thrown. This line throws an exception with a message invalid operator if the provided operator is not one of the expected values. This is a defensive measure to handle unexpected cases and ensure that the function behaves predictably. Overall, the calculation function takes two numbers and an operator, then performs the corresponding arithmetic operation and returns the result. Fourth problem statement is to write a function called count occurrences that takes in string and a character and returns the number of occurrences of that character in the string. Now we can move to the solution. This line defines a function named count occurrences that takes two parameters, str, which is the input string to be searched, and a chr, which is the character whose occurrences we want to count. Both parameters are type string. This line initializes a variable count to store a count of occurrences of the character chr. It starts with the value 0. This line starts a for loop that iterates over each character of the input string str, starting from a character index 0 and ending at the last character index str length minus 1. If the current character is equal to chr, the count of the variable is incremented by 1, indicating that we found one occurrence of the character chr in the input string. This line checks if the current character at the index I of the input string str is equal to the character chr that we want to count. Finally, after the loop has iterated over all characters in the input string, the function returns the total count of occurrences of the character chr. Overall, when you call the count occurrences function with the string str and the character chr, it will return the number of times the character chr appears in a string str. This function provides a simple and straightforward way to count occurrences of a specific character within a string. The fifth problem is write a function called find max number that takes in a list of numbers and return the largest number in that list. Now we can move to the solution. This line defines a function named find max number that takes a single parameter numbers, which is a list of integers. This line initializes a variable max number with the first element of the input list numbers. This assumes that the list is not empty and there is at least one element in it. This line starts a for loop that iterates over the elements of the input list numbers, starting from the second element, means index 1, because we have already assigned the first element to max number. This line checks if the current element at the index I of the input list numbers is greater than the current maximum number stored in the max number variable. If so, we are updating the max number with the current element, making it the new maximum number. Finally, after the loop has iterated over all elements in the input list, the function returns the maximum number found, which is stored in the variable max number. Overall, when you call the find max number function with a list of integers, it will return the maximum number present in that list. This function efficiently iterates over the list once, keeping track of the maximum number encountered so far and updating it whenever the large number is found. The sixth problem statement is to write a function called title case that takes in a string and return the string with the first letter of each word capitalized. Now we can move to the solution. This line defines a function named title case that takes a single parameter sentence, which is the input string that needs to be converted to title case. This line initializes a new string variable str with the first character of the input sentence converted to uppercase. This ensures that the first character of output string will always be capitalized. This line starts a for loop that iterates over each character of the input sentence, starting from the second character, means index 1, because the first character is already processed outside the loop. This line checks if the character before the current character is space. If it is, then it means the current character is the first character of a new word. If the previous character was space, the current character is added to the str string after converting it to uppercase. This effectively capitalizes the first letter of each word. Else, if the previous character was not space, it means the current character is part of the same word, so it is added to the string str without any modification. Finally, after the loop has processed all the characters in the input sentence, the modified string str is returned, which is now contains the input sentence in the title. Overall, the function iterates over each character of the input sentence, capitalizes the first character of each word, and returns the modified string in the title case. The problem number 7 is to write a function called reverse string that takes in string and return the reverse of that string. Now move to the solution. In this section, we really focus on loops without using any built-in methods. So try that first. If you're stuck, you can always use the built-in methods to solve the problem. The highlighted line defines the function named reverse string that takes a single parameter sentence, which is the input string that need to be reversed. This line initializes a new string variable reverse with the last character of the input sentence. This ensures that the first character of the reverse string will be the last character of the original string. This line starts a for loop that iterates over each character of the input sentence, starting from the second to last character, that is sentence dot length minus 2, because the last character is already processed outside the loop. Inside the loop, each character of the input sentence, starting from second to last character, is appended to reverse string. This effectively reverses the order of characters. Finally, after loop has processed all the character in input sentence, the reversed string reverse is returned. Overall, the function iterates over each character of the input sentence in the reverse order and builds a new string by appending each character. The result is reversed version of the input string. Problem number 8 is to write a function called isPalindrome that takes in string and returns true if the string is palindrome and false if it is not. Now, what is palindrome? A palindrome is a word, phrase, number or other sequence of characters which reads the same backward and forward. An example of a palindrome is race car. Now let's jump into the solution. Is palindrome as a written type boolean and which takes in string named sequence as the input parameter. This line formats the input sequence by converting all the characters to lowercase using two lowercase method. Removing non-alphanumeric character using replace all methods with the regular expression pattern. This pattern matches any character that is not in the range of lowercase alphabets or numeric digits. The caret symbol inside the square brackets negates the character class, meaning it matches any character that is not in the specified range. The formatted string will contain only lowercase alphanumeric characters. This line reverses the formatted string by splitting the formatted string into list of characters using split method, which splits the string into individual characters, reversing the order of elements in the list using reversed method, joining the reversed list of characters back into the string using join method. The resulting string reversed str will be the reverse of formatted str. This line compares both the variables. If they are equal, it means the original sequence is a palindrome and the function returns true, otherwise it is false. Overall, the function first removes non-alphanumeric characters and converts input into lowercase, then compare the formatted string and it reverses to determine if it is palindrome. The problem number 9 is to write a function called count vowels that takes in string and return the number of vowels in that string. Let's move on to the solution. This line defines a function named count vowels that takes in a single parameter sentence, which is the input string in which vowels will be counted. The function is expected to return the count of vowels found in the input string. This line initializes a variable count to store the count of vowels found in the input string. It starts with the value 0. This line defines a list named vowels containing the vowels A, E, I, O, U. These are the vowels that the function will look for in the input string. This line converts the input string sentence to lowercase and assigns the result to a new string variable scn. This ensures that the function is case sensitive when searching for vowels. This line starts a for loop that iterates over each character of the input string scn. This line checks if the current character at the index I of the lowercase input string scn is included in the list of vowels defined earlier. If the current character is vowel, then the count of the variable will be incremented by 1, indicating that a vowel has been found in the input string. Finally, after the loop has processed all the characters in the input string, the function returns the total count of vowels found, which is stored in the variable count. Overall, when you call the count vowels function with a string sentence, It will return the number of vowels found in the string. This function is case sensitive due to conversion of input string to lowercase, and it counts each occurrence of a vowel separately. The last problem in this video is to write a function called remove duplicates that takes in a list and returns a new list with duplicates removed. Let's jump into the solution. This line defines a function named remove duplicates that takes a single parameter list, which is the input list from which duplicate elements will be removed. The function is expected to return a new list containing only unique elements from the input list. This line initializes an empty list named unique list to store unique elements from the input list. This line starts a for loop that iterates over each element of the input list. Inside the loop, this line initializes a boolean variable is present to false, which will be used to check if the current element is already present in the unique list. This line starts another nested for loop that iterates over each element of the unique list, checking if the current element of the input list is already present in the unique list. This line checks if the current element of the input list is equal to the element in the unique list, then the is present is set to true. In this line, the loop is terminated early using break, as there is no need to continue searching once a duplicate is found. After the inner loop completes, this line checks if the is present is still false, indicating that the current element of the input list is not a duplicate. If the current element is not duplicate, it is added to the unique list. Finally, after the outer loop has processed all the elements in the input list, the function returns the unique list, which contains only unique elements from the input list. Overall, when you call remove duplicates function with the list, it will return a new list contains only unique elements from the input list, preserving their original order. These functions iterate over the input list and check each element against the element already present in the unique list, ensuring that only unique elements are added to the unique list. This entire concept is borrowed from Brad Traversy's Traversy JS challenge. By thanking him, if you are interested in, check it out. Link will be in the description. That's it for this video. Share your thoughts and opinions in the comments below. Thanks for watching. Catch you guys in the next video.